Hello, I'm Charlie, and today I'm going to be going over the algorithm to convert a NFA to a DFA. So the first string, or the first regular expression we're going to convert is this one here, A star, B, A star. So this represents all strings that start with an A and contain only one B. So to get started, let's make our NFA here. So we will have our first state here, state 1, and it can have as many A's because of A star. And then also we need to have one A before we can continue. So one A will come here into state 2, and all state 2 does is act as an intermediary for state 3. And state 3 here will take 1B, or 2 B goes to 3, and it's an except state because we now have 1B. Finally, we'll take A or this state 3 and loop it back to itself with an A because of A star. So it can have as many A's after it, but once again, any B's will fail here. And this is our NFA for this string here, where we're required to do an A and a B, but any other B's will fail, and we have these two loops for the A stars here. So now, let's convert this to a DFA. And I'm going to do this using two different methods, and I'll do both together at the same time. So first, I'm just going to move this up here, out of our way. And let's get started. So we're going to be using two methods here. So we're going to be using a table method. Here we have our state and the set, which I will explain in a second. And then also our character. So we have A and B. And now over here, I will be doing the graphic version. So we start off with our set that contains our starting state. So 1. The sets will be where we are at any given moment in the NFA. Because of these choices here, we don't know where we will be at any given time. So the only guarantee is that we are in one of the things in this set. So to start, we are in the set of 1. And when I'm writing out these sets, I like to, kind of in the top somewhere, just list out on my paper what exactly can happen. So from A, if we get, or from 1, if we get an A, we can go to state 1. Or we can go to state 2 here. So if we get an A, we can go to 1 or 2. Now, because we don't have that state yet, we have to draw a new state that contains the set of 1 or 2. And here we have A. Now, before I continue on here, I just want to go to the table notation. So this state number and the set are completely different from each other. But this is a way that helps me organize how I do the sets. So from 1, if we get an A, we need to go to the set that has 1 and 2. Because we don't have that yet, in our table notation, we're going to make a new set that contains 1 and 2 here. And we're going to call that state 2. Once again, these numbers are completely unrelated from the set numbers here. And this goes to state 2. So 1, if we get an A, we're going to go to state 2, which represents this number 2 here. Now, if we get a B, for example here, B, well, in our NFA, 1B goes to nothing. So because of that, we have to create the empty set. And I'll create the empty set down here. So the empty set is the set that contains nothing. So B goes to the empty set, and the empty set will always loop back to itself because A or B from nothing will go to nothing. So this is what we'd call like a dead state, and this just means our our string has failed, but we need to continue going through it until the end. So once again here, we don't have a state to represent the dead state, so we create a new one here. So this is our empty set, and number 3. So 1b will go to state 3. Now we can continue and look at the next set, so state 2 here. And for this table notation, I just, I keep going through it until everything is mapped to something. So you'll keep adding in these different sets until you find that there's no more sets to add and your entire table is filled out. So from A here, if we get a 1, or from 1, if we get an A in our NFA, it can go to 1, or it can go to 2. So if we get an A here, it will just loop back to itself. And in our table notation, we have the set 1, 2 already defined, so 2A goes to 2, because that is that's the state that contains the set 1, 2. Now for B, we have to look at all of the sets in here. I didn't go over that earlier, but we have to look at every single set. So when we were looking at A, from 1 here, 1A goes to 1, and 1A goes to 2. And from 2, 2A goes to nothing. So we were just left with 1, 2. And now in this example here, you'll see 1B doesn't go anywhere. But that doesn't mean we go to the empty set, because we have to look at every single state in our set here. So if we look at the 2, 2B goes on to 3. So now we need to define a new state, because we don't have a set for that yet. So here we have set that contains 3. We'll call that state 4 here. So 2B will go to 4, and I will draw that in our diagram here. So B will go to this state here, which is an accept state, and it contains the set of 3. And this is an accept state because it contains an accept state from the NFA. So if you have a set that contains any number of, states in here, if one of them is an accept state, then the entire state will be an accept state itself. So even if I had 3, 1, and 2, even if this was the set of all 3 states here, it would still be accept because we have that 3, our accept state there. So now, if we look at the empty set here, once again, it will just go to itself, so we don't have to fill that in. And now finally, we look at this last state here. So from state 3, if we get an A will go to state 3. So it will loop back to itself. Or let me define it up here. So A will go to 3. So A loops to itself. And down here, it will go to itself. And if we get a B, we'll see that it doesn't have anywhere to go. 3B goes nowhere. So we go to the empty set. So here, B goes to the empty set. And once again, down here, 4B will go to 3. And now our table is filled in. So we're done. And also, if you look at our DFA here, every single node, every single state has exactly two characters coming out of it, because our language is AB. So we only have A and B to look at. So this is it for this this DFA. So, and if we give it an example string, so let's look at A, A, B, A, for example. We start at state 1 here. We have A, then we loop A, we have the 1B, B, and then A, and we end up in this accept state. But if we added in maybe a B here, for example, AB, we have 1A goes to here, B, A, but then we hit this second B here, and we go to our dead state, where A will loop to the dead state, and we would reject this string because it doesn't contain exactly 1B. So that is it for this DFA. So I'm going to do one more example that's a little more complicated. But yeah, I'll pause the video right here, take a screenshot, and if you still don't understand, leave a comment and I can try and help out.